Researchers say we need to be personalizing our ketogenic diet based on our genes. Find out the details here today on Jimmy Rants. JimmyRants.com is the website, and as always, you can engage live in the content. You got to go follow me. I'm right here over on Instagram. Go look up Jimmy Rants over on Instagram. That's where the fun begins. We do go live 11 a.m. Eastern Time, Monday through Friday. So thank you so much for being here. We also simulcast live over on Twitch, Facebook, and on YouTube. Lots of ways to watch the show live. If you can't catch it live, be sure to watch the replay. We put it up over on IGTV, over on the Jimmy Rants Instagram page. I do usually put up a little tidbit, like a 15-minute snippet of this on my Living Low Carb Man page. And a lot of people watch the snippet, but the full shebang is on the IGTV at Jimmy Rants. You can also watch the full shebang over on YouTube. We put all the past episodes up over there as well. And we also put the past episodes at the official website for this show, JimmyRants.com. No matter what happens with all the censorship that's going on, you will always be able to find Jimmy Rants over at JimmyRants.com. Okay, you guys, thank you so much for being here today. I have a really great episode in store for you today to tell you about a brand new paper that got published in a journal by 4 really prominent ketogenic researchers. Now, I've been talking about ketogenic diets, we back up. I've been talking about low-carb diets for over 15 years. And ketogenic diets, really specifically, I started testing that nutritional ketosis back in 2012. And even then, as I was doing my N=1 experimentation of nutritional ketosis, which ended up turning into this book down the road, even then, I was telling people, don't try to mimic what I'm doing. What I'm doing is what I'm doing because it's what's working for me. And I think part of the confusion that comes into play when it comes to the ketogenic diet is people think it's formulaic. And so when you make something formulaic that was never intended to be formulaic, in other words, like macronutrient ratios, like all these people that want you to have a percentage of this macronutrient and the percentage of that, and so you're trying to fit your macros. That has always been weird to me because that doesn't really personalize it to the individual. And then some people tend to need more protein. Some people tend to do better with more fat. Even some people do pretty good with more carbohydrate. And so it's kind of, how do you personalize that ketogenic approach for you? And so I have a brand new paper that has 4 of the biggest names in the research world when it comes to ketogenic diets. And they make the argument in their paper, which I'm going to read today. They make the argument that we need to be looking at genetic factors and other lifestyle factors in individuals to help them figure out how to personalize their keto. Now, that seems elementary, but think about this. A lot of this genetic testing has only come along in the past few years. And so when I even first started blogging back in 2005, none of this stuff was at our fingertips. None of this stuff was available. Now we have so many more tools. We have so many more ways to test for things. And in that testing, we can see, okay, you're going to tend to do a little better with more saturated fat. You're going to do a little better with less carbohydrate and da-da-da-da-da. Whereas someone else may get some genetic markers where, oh, you're going to need to prioritize protein first. You're probably one that doesn't necessarily need to be full on keto all the time. Maybe you cycle in and out. So having these tools at our disposal, I really think this is the next wave in nutrition and health. And everybody likes to ask me, because I got very fortunate writing Keto Clarity, was way ahead of the curve on keto. They're like, what's the next diet trend? And really, like, in my gut, I don't think the next diet trend is a diet at all. I think the next trend in nutrition, the next trend in health is customizing the diet that's right for you. Now, you can't get a big splash promoting a customized diet. But quite frankly, I don't care about splash. I care more about what's going to actually help people. So if you're just joining us, I am about to read from a paper from some researchers, ketogenic researchers, who promote creating personalized keto plans based on your genetics. And so the paper was published in the BMJ, British Medical Journal, Nutrition, Prevention, and Health. So this is a journal that tries to help people and researchers put out information that would help people determine their nutrition and preventative care and being healthy. The title of the paper, Genetic Variants for Personalized Management of Very Low Carbohydrate Ketogenic Diets. And the four researchers, I know all four of these people personally. Lucia Aronica, she's kind of a new kid on the block. She's at Stanford, where Christopher Gardner is her mentor. Christopher Gardner did the A to Z study way back in the day in like 2007. Huge study that showed low-carb ketogenic diets have efficacy, and he's a vegetarian. And so Lucia now works for him. Dr. Jeff Volek, who needs no introduction. Him and that guy back there, Steve Finney, have done a lot of research. In fact, Dr. Volek wrote the Art and Science of Low Carbohydrate Living, which I actually had a chapter in that book, which is why it's by me. So he was one of the co-authors. Angela Poff is another new kid on the block that's out there doing some great research. She's a part of the Metabolic Health Summit that takes place in California, Long Beach. I'm not sure if they're doing one next year because of 9/1 DIVOC, but she's one of the researchers on here. And then Dr. Dominique D'Agostino, who is Angela Poff's colleague in the research world. And of course, Dom has done an amazing job looking at ketosis, looking at really every angle of ketogenic diets, especially exogenous ketones, Navy SEALs, da-da-da-da-da. So, as you can see, superstar group of researchers that wanted to look at this question of how do we personalize a low-carb ketogenic diet by looking at key genetic markers. Now, I'm going to warn you ahead of time. These are some nerdy people, and so they write really nerdy. Now, Jimmy is good at translating nerd, but as you have seen before when I've gone over papers, I sometimes struggle with the words because it's a little nerdy, but I'll try to give you the gist. There is one part in here. Please stick around, guys. Don't go anywhere. There's one part in here where if you have high cholesterol after you went keto, and you're like, oh my God, what's going on? Why do I have high cholesterol? They actually have a sidebar in this paper which explains all of us, I'm one of those people, all of us who tend to have higher cholesterol when we eat a ketogenic diet, they have identified what they think might be a genetic marker that would indicate what that's all about. So stick around for that. When we get to that, I will definitely highlight it for you. But let's read the paper. In the abstract, it says the ketogenic diet is a low carbohydrate, high fat, adequate protein diet. It's proven to be effective for the reversal of obesity, metabolic syndrome, and type 2 diabetes, and holding therapeutic potential for the prevention and treatment of all kinds of chronic diseases. Genetic and dynamic markers of ketogenic diet response may help identify individuals most likely to benefit from the ketogenic diet and point to individuals at higher risk for having adverse health outcomes. That's one of the things that, since I've been online, oh my gosh, you eat that low carb diet, oh, that, you're going to clog your arteries and hurt yourself, and they've just kind of thrown these things out there. And perhaps it was with good intentions that a lot of those warnings were put out there about low carb diets, but it was never an across the board thing. And so what these researchers are doing is, okay, maybe there are a few individuals who have a higher risk for adverse health outcomes, but let's look at what could predict that before we put them on such a diet. Could you imagine if you went to your doctor and you said, hey, I want to lose weight, I want to get healthy, and the doctor's like, all right, let's run some genetic tests to see what would work best for you. How cool would that be? Now, mainstream medicine, it's not going to happen, but a lot of functional medicine doctors do run this kind of genetic testing. In fact, I am in the process right now. The kit is on the way. Dr. Ben Lynch has a new book called Dirty Genes, and Ben reached out to me on Instagram recently, and he said, hey, I've had this new book. I'm like, yeah, I want to interview you on my podcast. He said, I want to do something else. I want to run a full genetic kind of markers test on you. And I'm like, yeah. So I never turned down getting genetic markers. I know my MTHFR. I know various markers, but it would be really cool to know a full array of them. And so there are practitioners out there like Dr. Ben Lynch and others and a lot of functional medicine doctors who do run a lot of genetic tests, which then helps guide them about what diet and what supplements and things will work for the individual. Here we provide a clinician-friendly review of the state-of-the-art research on biomarkers of ketogenic diet response for a variety of outcomes, including weight loss, body composition, cognitive performance, drawing data from both intervention trials, that's where they directly go in and have them do a specific protocol, and case reports of rare inborn errors of metabolism. So this is where people have had something happen to them and they do a case report. That's the kind of study. We also present a selection of the most promising candidate genes to evaluate in future studies. So the hope with this paper is we'll identify what we think are the genetic markers. Now, researchers go out there and go prove it. And we discuss the key aspects of study design and variant interpretation that may help accelerate the implementation of these biomarkers in clinical practice. Yeah, part of the issue is they think they're testing keto and they're not testing keto at all because the carbohydrates are too high. We've talked about that before in other studies. I've seen studies where the carbohydrate intake is as much as 45 to 50% and they're calling it keto. And no, it's not low carb in any way when it's 45 to 50% of your calories. All right, let's get into this. And if you just joined us, we are reading from a brand new paper published in the BMJ Nutrition, Prevention, and Health. The title of the paper, and I'm saying all this because people always complain when I post this to YouTube and various places. I need a link to the study. Well, Google this, DuckDuckGo this, genetic variants for personalized management of very low carbohydrate ketogenic diets. Again, BMJ Nutrition, Prevention, and Health. The researchers Aronica, Volek, Poff, and D'Agostino. So go look it up if you want to look at it yourself. Introduction. As the field of precision medicine is gaining traction, nutrition research is experiencing a gold rush for biomarkers that may enable the selection of personalized dietary intervention to maximize an individual's likelihood of a successful response. These biomarkers include both genetic factors and dynamic biomarkers that respond to lifestyle factors, things like physiological markers, epigenetics, transcriptomics, metabolomics, and the microbiome. So these are all things that have been readily available for clinicians to use. They just have not used it because they don't know what to do with it. The use of biomarkers of dietary response would be of particular clinical relevance for the selection of individualized risk-benefit analysis of therapeutic diets, things like the ketogenic diet, which provide alternative or complementary therapies to standard of care treatment. So doctors have to follow this whole standard of care, which means they have set guidelines of when patient exhibits X symptom, this is the care that you give them. This is the ICD code that you use so that their insurance pays for it and da-da-da. What if they added in some of these markers as part of the protocol in conjunction with the standard of care? Right now, most doctors keep head down standard of care, head down standard of care, head down standard of care, and they're not looking at the patient. They're not seeing if maybe there's something in their family history that could be contributing to why they have said condition that they're dealing with. And so what this study aims to do, what this paper aims to do, is to get it on their radar screen of, hey, we've got all these tools at our disposal, let's start using them. The ketogenic diet is a low carbohydrate, high fat, adequate protein diet. It was historically used to treat epilepsy and diabetes a century ago, prior to the discovery of insulin and anti-seizure medications. The latest scientific evidence shows that ketones are both preferred fuels and potent signaling molecules that dramatically increase the number of investigations into the basic science of ketones and their applications across broad disciplines. Ketones demonstrate, and here we go with some of the words that I'm going to have to struggle with, pleiotropic actions affecting gene expression and pathways, things like inflammation, oxidative stress, immune function, membrane health, cell signaling, and antioxidant status that then manifest in the reversal of metabolic disease and extended health span. So all of these things are what lead to disease: inflammation, oxidative stress, immune function disorder, membrane disorder, cell signaling is off, antioxidants are off. When those things get corrected, then your health improves. And so what they're saying is a ketogenic diet is what makes that reversal of all those things take place. The most remarkable therapeutic evidence of ketogenic diets is the rapid and sustained reversal of obesity, metabolic syndrome, and type 2 diabetes in a plethora of recently published research. Preclinical and other evidence points to ketogenic diets as a promising therapeutic intervention in other chronic diseases, things like Alzheimer's disease and certain types of cancer. In fact, when we wrote Keto Clarity 6 years ago, we put in there that that was where the emerging evidence for ketogenic diets was happening. And it is. And now today we have a lot more research all about things like Alzheimer's and other cancers. Ketogenic diet also induces a metabolic switch from using glucose to fat as a primary fuel for the body. There are different variations of the ketogenic diet. The most commonly used protocols recommend 30 to 50 grams or less of dietary carbohydrate, 25 to 30 grams of net carbohydrates per day. And when you do that, you create beta hydroxybutyrate, BHB. Some of this is going to be very familiar to those of you that follow my work, but stick with me because it's going to get good here in a minute. BHB and acetoacetate are the two main ketone bodies in the blood that are produced from partial oxidation of fatty acids. Both ketone bodies and fatty acids are important sources of energy for the brain, the heart, muscles, kidney, and other tissues when glucose availability is limited, such as carbohydrate restriction or fasting, or when energy demands become increased through exercise or through illness. So, what they are calling for here in their paper is a personalized lifestyle approach to the ketogenic diet. And by doing so, you would enable to maximize both the therapeutic effectiveness and the long-term safety for patients. This is something that since I first started blogging a decade and a half ago, they were always worried about, oh, it's not safe, it's unsafe, you're gonna harm yourself if you go on a ketogenic diet, it's not safe. And yet those safety things never really bore themselves out in the scientific literature. In fact, just the opposite. It's unsafe to stay sick. And so what keto does is it helps you not be sick anymore. That's what's unsafe. Although the ketogenic diet has proven to be effective and safe for most people in the trials that have gone up to 2 years, the degree of therapeutic response in terms of weight loss, metabolic changes, and neurological effects will vary from individual to individual. That frustrates people, by the way, because you see your friend go on a ketogenic diet and they lose X amount of pounds and they reverse their type 2 diabetes and they have all these great things happen, and then you go on the exact same diet and you don't see those results. Well, they're trying to elucidate why that happens in this paper. In addition, there are physiological factors such as your sex, your age, and this variability likely reflects the interaction of those genetic and lifestyle-related factors. Things like what's in your diet, your level of insulin resistance, which remember, there's 88% of the population is dealing with some semblance of the insulin resistance spectrum, which is almost everybody. And your activity level also plays a role. As ketogenic diet and personalized nutrition are becoming more and more popular, genetic variants for the prediction of ketogenic diet response are increasingly discussed in media articles, blog posts, and direct-to-consumer genetic reports. However, most of these variants have not been evaluated in intervention trials of the ketogenic diet. So they recognize that there are differences, but they haven't looked at why there are differences. And they say in this paper that misleads and confuses consumers and their health practitioners. So maybe in the popularity of keto, and somebody bought Keto Clarity and they read the principles, or one of the other keto books, read the principles of it and learned all about it and tried to kind of really get into it and do it properly. And then they're not seeing the results. They think, oh, keto didn't work. How many people have told you that you went keto and you've had great success, but then other people, well, I tried keto, but that didn't work. Well, maybe it wasn't that keto didn't work. Maybe it was that keto, the way they were doing it, was wrong for their genes and their lifestyle. Maybe keto needed to be more personalized to them, which is, again, what they're trying to do here. And by just saying, just go keto and your health and your weight will get better, that's not enough. We need to know, okay, what kind of keto is going to work for that person. So the main aim of this review is to provide clinicians and patients with a snapshot of clinically tested common single nucleotide polymorphisms, SNPs, for the prediction of the ketogenic response. And what they did is they ranked them by their strength of scientific evidence. So remember, the 4 people in this study, Lucia Aronica, Dr. Jeff Volek, Dr. Angela Poff, Dr. Dominique D'Agostino, they're all doctors. They know all of this scientific evidence. And they know what's good evidence, what's bad evidence. And so they're ranking this based on that strength of evidence. So these SNPs have been identified in various intervention trials, testing the effects of the ketogenic diet on various outcomes, things like weight loss, body composition, and cognitive performance. In addition, they provide a list of rare mutations with strong effects on the ketogenic diet's response, either as a therapeutic indication or contraindication, and they present a selection of the most promising candidate genes and the approaches that need to be looked at in future studies. Finally, they will discuss the importance of establishing common standards of the design of studies and variant interpretation, and then delineate the steps needed to be taken towards the implementation of these guidelines. So you guys ready to get into this? They're going to look at the common SNPs, and that's just basically those little genetic parts of your body and that can be seen and tested, associated with metabolic or neurological outcomes in intervention studies of ketogenic diets or ketogenic agents. All right, we're about to get real fast, so stick with me, guys. Those of you that are nerdy into the science, this is the Jimmy Rants for you. Thank you for being here today, you guys. Genetic variation may influence ketogenic diet response by affecting the body's ability to process and use carbohydrates or fats, while rare mutations can produce strong effects on phenotype. Common result in more subtle effects that depend on the interaction with other genetic variants and environmental factors. Genome-wide association studies have identified many of these SNPs associated with inter-individual differences in the response to a high-fat food intake. However, most of these genome-wide association studies were observational studies based on populations that consume diets high in both fat and carbohydrate. So a lot of those studies, they'll call it a high-fat diet, but it's a high-fat and a high-carbohydrate diet. So that's, the carbs are a confounding variable. So when you have both a high-fat and a high-carb diet, it's often referred to as obesogenic high-fat diets. I love that distinction, by the way, because when you say high-fat diet and it's high-fat in the presence of low-carbohydrate, it's a far different category than a high-fat in the presence of high-carb. So by calling a high-fat, high-carb an obesogenic high-fat diet, you know they're eating carbs in that diet. So these obesogenic high-fat diets are associated with SNPs such as the PPARA gene. They're commonly but misleadingly listed as a contraindication to the ketogenic diet. In other words, because it's high-fat, they're like, oh, it's ketogenic, but it's high-carb as well. So I love the distinction that these guys are making in this paper. Since the metabolic, hormonal, and neurological effects of these obesogenic high-fat diets are diametrically opposite to those of the ketogenic diet, we do not have any evidence for the use of these obesogenic high-fat diet associated SNPs for the prediction of ketogenic diet response. So they're just saying, okay, practitioners, all right, doctors, you're out there looking at these patients. Make sure that if they're eating a high-fat diet that they've got their carbs low. Because if they're also eating high carb with the high fat, it's definitely going to pack on the pounds and lead to metabolic distress. Only a few of the intervention studies have tested the effects of this obesogenic high-fat diet SNP on weight loss and body composition in the context of trying to get the person into ketosis. There are SNPs as well as other ones that are associated with individual differences in the neurological response to ketogenic diets. A strength of evidence score is provided for each of these SNPs based on recent guidelines for the interpretation of neurogenic variants. So they show a table here. They referenced it. Yeah, so this gets a little bit in the weeds. I mean, I could definitely go look up this paper. Once again, go look it up. Genetic variants for personalized management of very low carbohydrate ketogenic diets. Just know there are various SNPs that they list here, and they're all listed here with kind of some of their effects. I don't want to get bogged down too much to that, but it shows you the what the SNP is. You get the code, and then you get the enzyme function, what the outcome is, which in this case is all weight loss, and then what the response to the ketogenic diet would be with those specific SNPs. But let's move on to the SNPs that are associated with weight loss and body composition outcomes. A study in 86 adults found that SNPs in genes encoding for the metabolic enzymes gastric lipase, and it's going to get a little in the weeds here, so stick with me on this. So that gastric lipase, LIPF is what that's called. Hepatic glycogen synthase, GYS2. There will be a test at the end, by the way. I just thought I'd let you know. You got to remember. No, don't worry about that. Cholesterol ester transfer protein, that's RS5883T. And galanin, which is RS694066G. All of those were significantly associated with a greater weight loss in those on the ketogenic diet when they went on for 4 to 12 weeks. So there's a study that looked at all of those kind of genetic markers. You can have these markers run. That's the cool thing. Every one of these markers, these genetic markers, are available at your disposal. So if you have this LIPF, or if you have this GYS2, or the other ones that I listed here, maybe a ketogenic diet works for you for weight loss. Another study compared the effects of the ketogenic diet versus a low-fat diet. So that ketogenic diet had carbohydrate at around 12%. The low-fat diet had fat at around 25%. And so they looked at weight loss and body composition and the association of the effects with genetic variants. The minor G allele of the RS5950584 SNP in the promoter region of the angiotensin 2 receptor gene, that's ATTR2, was associated with a greater reduction in body fat percentage with those who went on a ketogenic diet. Again, I highly encourage, go look up this paper. I know it's hard to translate as I'm talking to you over video, but just trust me, these are all SNPs, these little genetic markers that can be run where you can know where you stand and whether a ketogenic diet puts you at a better genetic advantage to see the results you're looking for. So this AGTR2 gene has been implicated in the accumulation of fat and the development of muscle cell IR, insulin resistance, induced by the high-fat hypocaloric feeding in mice. Men can only have either the T or the G allele, while women may have 0, 1, or 2 copies of this. This means that the effect of this gene variant on fat loss with the ketogenic diet may be more prevalent and stronger in men than women. So all you ladies that get frustrated about how easy it is for us guys to lose weight on a ketogenic diet, there's your answer. We have a genetic marker, the gene AGTR2, which can have either the T, the major, or the G, the minor allele, while you ladies may have none, one, or both. And that makes the difference as to why guys lose weight better and faster than women. See, all these years you were frustrated and you had no idea that it was a genetic marker. And it does have to do with your sex. And so as a guy, it will be easier for me because I'm either one or the other. But you ladies that may have none, maybe that's where the problem takes place. Is this fascinating, guys? I hope it is. I hope it's helpful to you. The major G allele in that genetic SNP of the RARB gene was associated with greater reductions in body fat percentage within both the ketogenic diet and the low-fat diet groups. This RARB gene encodes the retinoic acid receptor beta, a thyroid steroid hormone receptor which regulates energy production in the liver through the modulation of gene expression. This observation is noteworthy in light of the putative role of the retinoic acid system in the development of insulin resistance. Other genetic variants were associated with a greater reduction in body fat percentage within the low-fat group only. Listen to this. If you have these genetic variants, low-fat may be better for you. These include the major G allele of the RS12691940 SNP, of the HNMT gene. I know it gets in the weeds. Stick with me, guys. Which has been implicated in appetite regulation in mice. And then the major G allele of RS283 8549 SNP in the PFKL gene, which produces a key regulatory enzyme for glycolysis known as hepatic phosphofructokinase. So all of that to say that there are certain genetic markers that could be helpful to you if you have them run and you kind of run them across a chart that says, okay, if you have these genes, maybe a low-fat diet works better for you than a low-carb, high-fat diet. Maybe those of you that have tried to force a high-fat diet on yourself and you've got these genes that make it where you do better with a low-fat diet. See where I'm going here? Now, again, you're going to need to work with a practitioner that understands these SNPs and what they mean and how to customize. But you can see already, this is how you can customize your plan to you and your genetic markers, right? So let's move to neurological outcomes. Using a discovery approach, a recent intervention study in epileptic children found that a SNP within the chromodomain Y1 ligand, CDY1L, may affect the seizure ketogenic response. So a lot of kids go on the ketogenic diet to try to control their seizures, and it doesn't work with everybody. And for the longest time, I remember interviewing Dr. Eric Kossoff from Johns Hopkins many years ago now, talking about, and he's a researcher looking at epilepsy and ketogenic diets, and he says, yeah, for some reason, we don't know why, but the ketogenic diet doesn't work in all kids, but the kids it does work in, it works brilliantly. Now we know this CDY1L is what's affecting whether the ketogenic diet works or not. CDY1L is a chromodomain protein and histone acetyltransferase with important roles in epigenetic regulation of the gene expression in your brain, which makes sense if you've got seizures. In this study, there were 232 epileptic children between the ages of 3 and 9 who went on the ketogenic diet for 3 months. Children carrying at least one copy of that particular gene they represented 17% of the general population, and almost 50% of Africans experienced a lower seizure reduction when following ketogenic diets compared with those who did not carry that gene. The underlying mechanism of this gene-diet interaction are unknown, as is true with many things, but might involve differences in ketogenic diet-mediated gene expression changes in the brain. So, this is exciting research. Like, I'm sure Dr. Kossoff and his team there at Johns Hopkins is already looking into this, because this paper kind of is a culmination of a lot of the things they've already known out there. And Dr. Kossoff is really good friends with all these researchers in this paper. So I'm sure they've already put it on his radar screen. Other neurological studies have used a candidate gene approach to investigate the effects of genetic variation on the ApoE genotype on cognitive performance in response to the ketogenic diet or ketogenic agents in AD patients. ApoE, which I've talked about ApoE genotype in cholesterol clarity. We put that in there. So ApoE is a genetic marker. You run it one time and you know what it is. And that's the one where if you have a 4, it tends to mean you have to change your diet a little bit for heart disease things. A 2 in there also has brain health implications, and 3 seems to be the safe. And most people are a 3-3. So 70% of the population is 3-3 on the ApoE genotype. That's what your host is. I'm a 3-3. If you are a 4-4, that's usually like those people die by the time they're 50. Now, it's not a death sentence, but it certainly puts them at a worse risk. And then 2-4, I mean, there's just all kind of little markers that could be problematic. So ApoE is the principal cholesterol carrier in the brain, helps to clear both cholesterol and triglycerides from the bloodstream. So those who have a 4-4 tend to have a lot of cholesterol in their bloodstream and it can't clear, and that's why it's problematic. About 30% of people have at least one copy of the 4, so almost 1/3, which has been associated with a 4-fold to 15-fold increase in the risk of Alzheimer's disease compared with individuals with the more common 3 allele, while the 2 allele is related to a decreased risk, at least of Alzheimer's disease. However, lifestyle plays a major role in modifying that 4 with the Alzheimer's risk. And although the 4 allele is most frequently seen in African populations, the incidence of Alzheimer's disease in elderly Nigerians is actually extremely low. 4 carriers are more likely to develop Alzheimer's disease if they have high levels of insulin resistance. And that's where keto comes into play. Because if you go keto and you help heal the insulin resistance, then maybe that expression of that 4 in your ApoE genotype isn't going to harm you near like it would if you left the insulin resistance unabated. So it's been proposed that this ApoE4 and insulin resistance interacts with the 4 variant to produce impaired glucose metabolism, so your blood sugar stays wackadoodle. Insulin sensitivity is also off. Lipid transport to the brain, leading to the accumulation of amyloid beta, and you don't want that. You really don't want that. And ultimately, cognitive failure, which is what you get in advanced Alzheimer's disease. The underlying mechanisms of this interaction are not fully understood and may reflect biochemical differences between the different ApoE isoforms, things like susceptibility to glycosylation, effects on brain glucose metabolism through the regulation of cystosylic hexokinase. I told you there would be some words that would throw me. And the delivery of lipids to the brain. The ketogenic diet could alleviate the effects of these alterations and improve cognitive symptoms in patients with Alzheimer's disease by reducing the insulin signaling in peripheral tissues and the brain and providing ketones as an alternative energy source. So once the brain has become damaged, and if there is a connection to this ApoE4, the ketogenic diet can actually help to express that gene in a different way, the whole epigenetic conversation, by freeing up the brain of the glucose and replacing the glucose with the ketones. This is exciting. Like this is kind of cutting edge research here, and I really hope there are researchers who take this idea and run with it, because it could be revolutionary, especially for those patients dealing with Alzheimer's disease. So preliminary evidence indicates that ApoE genotype may affect cognitive performance in response to elevations in the blood ketones, depending on the modality of how ketosis is achieved. Do you get it through a ketogenic diet, or do you take it through like exogenous ketones or ketone esters? And the way that you create the ketones matters, according to what they're saying here. It can affect the kinetics of cellular uptake of ketone bodies and their blood levels. I'm not a big fan of willy-nilly taking exogenous ketones or ketone esters and other kind of what I would say synthetic forms of ketones. Let your body make ketones. But if you're doing it for a therapeutic purpose, maybe that is a role for them. In a randomized double-blind crossover trial comparing a modified Mediterranean ketogenic diet versus American Heart Association diet, which is very low fat, over a period of 6 weeks, the ketogenic diet improved Alzheimer's disease markers such as accumulation of brain amyloid in both ApoE4 carriers and ApoE homozygous with mild cognitive impairment. They had no significant difference based on their ApoE genotype. This is in line with a case report of an ApoE heterozygous 71-year-old woman who had mild Alzheimer's and metabolic syndrome, experienced significant improvements in her cognitive performance and her metabolic syndrome markers. She saw her HOMA-IR score, which is an insulin resistance score, drop 75%. Triglycerides dropped in half. LDL also dropped in half. HbA1c went from 5.7 to 4.9. Huge changes after just 10 weeks on the ketogenic diet. She also did time-restricted eating, so a little bit of intermittent fasting in there, and did some physical and cognitive exercises. In contrast, greater carbohydrate intake is associated with poorer performance in attention in these people with ApoE genotype and poorer performance in verbal memory. On the other hand, the ApoE variant may have an effect on cognitive performance in response to ketogenic agents in patients with Alzheimer's disease. In a placebo-controlled trial in 20 patients who had mild cognitive impairment or Alzheimer's disease, the administration of MCT oil in the amount of 40 milliliters blended with 152 milliliters of heavy whipping cream produced improvements in their cognitive performance as assessed by the Alzheimer's Disease Assessment Scale Cognitive Subscale. Only in the ApoE3 homozygous, but not in the ApoE4. So if you got that 4 in there, it tends to be a little bit harder for those people. And again, that's the genetic marker. At the same time, ApoE4 carriers experience counterintuitively more prolonged elevations in their ketone levels in response to the MCT, suggesting that their lower cognitive response may reflect lower cellular uptake or utilization of these agents compared with the 4. So that's interesting. So the ketones are in the body, but they're not being uptaken. So those of you that like to test your ketones often and you're looking for higher and higher ketones at any given moment in your blood does not mean better. It could be that your body's not uptaking those ketones to go do the things it needs to do in your body. So keep that in mind and let that encourage you that, if you have lower levels of keto, oh my gosh, it's not working. No, it means your body's probably uptaking them. And if you have higher, don't fret about it, but it could be that your body just hasn't taken them up. These findings were replicated in a larger randomized double-blind placebo control of 152 Alzheimer's disease patients. They tested the cognitive effects of MCT-based supplement that was composed of glycerin and caprylic acid, which is a really potent version of MCT. They administered it over a period of 3 months. And while the AC1202 induced significant improvements in this, that's the caprylic acid, that's what that ABC123 was, these effects were greater and significantly correlated with blood levels only in those with the 4. I am talking my head off trying to get all this in, guys. All right, let's turn our attention to blood lipids and cardiovascular outcomes with these SNPs. One of the most clinically relevant and frequently asked questions amongst health practitioners and patients is whether some genetic variant may predispose someone to cardiovascular disease, like high LDL cholesterol. We've been told that in the context of a ketogenic diet. Although several cholesterol-raising genetic variants have been identified and associated with a higher cardiovascular disease risk in the context of obesogenic high-fat diets, there's still no evidence about whether these variants would be a contraindication to the low-carb, high-fat ketogenic diet. So they have a brief discussion of this topic along with some practical tips for clinicians managing patients who experience an increase in LDL in response to the ketogenic diet. So here's that sidebar, guys. I teased it at the beginning. So those of you that have higher levels of cholesterol after you went keto, take a listen to this. Cholesterol-raising genetic variants, a contraindication for the ketogenic diet? They're asking the question. 1 in 4 people experience an increase in their LDL once they follow a ketogenic diet. These individuals are often referred to as hyper-responders. While the biological mechanisms of this response are still unclear to researchers, we know that certain genetic variants may predispose some people to produce more cholesterol or reduce clearance of the blood of a high-fat diet. Several LDL-C raising common single nucleotide polymorphisms, that's the SNPs again, and rare mutations have been identified and linked to metabolic and cardiovascular disease in the context of a westernized obesogenic high-fat diet, where you have both high fat and high carbohydrate, especially refined ones. Examples of well-characterized SNPs associated with high LDL-C and metabolic traits, listen to these. So if you have any of these SNPs, and I highly encourage, try to find some lab that will run these genetic SNPs on you, because if you know these SNPs, it will inform you and it will put to rest some of your concerns you may have. All right, so here are some of the ones associated for those of you that have high cholesterol after going keto. Some of them include lipase C, that's a SNP. Hepatic type, the LIPC, which we talked about. And what that does, it gives a high LDL, high density lipoprotein, HDL ratio. Then there's ApoA2, and then there's ApoA4. So the ApoA2 results in higher body mass index. So if you have trouble lowering your body mass index, it could be because of the ApoA2. The ApoA4 results in a higher LDL and ApoB. That's me. Now, I don't have a Apo. I don't know what my ApoA is. I know what my ApoE is, but this is ApoA4. So I probably have that one. Higher LDL-C and ApoB. Always have. PPAR alpha results in high LDL-C and higher triglycerides with high saturated fat and low polyunsaturated fat. I know we love our saturated fat in the ketogenic world, but some people may do better not having as much saturated fat. As well as non-coding variants, things like SORT1, SORT1, which results in high LDL-C and a very high LDL particle number. So if you run an NMR lipoprofile test, you'll be able to see those particles for the LDL. Examples of rare LDL-C raising variants are those with genes implicated in FH, familial hypercholesterolemia, and other phenotypically related lipid disorders, which is a whole alphabet soup of all these disorders. However, there is still no evidence about whether these variants constitute any kind of contraindication to the ketogenic diet. So what they're saying is, because they do these effects, people might think, okay, well, that means I don't need to do keto. Not necessarily. They still haven't seen enough evidence that shows that these things are a contraindication. although some direct-to-consumer genetic reports make the claim. And there are a lot of these genetic companies, so be careful if you do have these genetic markers run with a company and they send you like a little leaflet that tries to interpret it for you. They will say, well, this means you can't eat a low-carb, high-fat ketogenic diet. May not necessarily be true. Some studies indicate that the increase in LDL-C that is observed on the ketogenic diet and other low-carb, high-fat diets reflects an increase in the LDL-C particle size rather than an increase in the number, a change associated with actually a reduced cardiovascular risk and accompanied by an improvement in other cardiovascular risk factors such as triglycerides and HDL. So I've talked about that very clearly many times, you guys, that when you eat a ketogenic diet, yes, you may see an increase in your LDL cholesterol, but it's an increase in the large fluffy kind, the pattern A on an NMR lipoprofile test. Pattern A is very protective. And so it may look like you have a lot of LDL, but it's the pattern A LDL, which is the large fluffy, can't penetrate the arterial wall. It's the pattern B, which is associated with higher carbohydrate intake, higher vegetable oil intake. All of those things is what makes those small BB-sized LDL particles, the whole pattern B, which then easily penetrate the arterial wall, lead to inflammation, lead to macrophages, lead to clogged arteries. That has nothing at all to do with the fat you eat. That makes sense? On the other hand, even large LDL particles could become atherogenic in the presence of genetic factors that reduce LDL clearance, such as familial hypercholesterolemia and lipid disorders. So if you have FH, and I've had a lot of people write me over the years. I went to see my doctor and he says I have a genetically high cholesterol. So I always ask those people, did they run the test from Ambry Genetics, AMBRY, that confirms that you have familial hypercholesterolemia? And they usually, 99.9999% of the time, no, they did not run that test. All they did was saw high cholesterol. And they just said, oh, you have genetic high cholesterol. Don't believe them. Have them run the test. Now, the test is like $1,200. So it's not a cheap test. But if you want to confirm if you actually have a genetic tendency for high cholesterol through familial hypercholesterolemia, you actually have to test for it. Therefore, at this point, we still do not have an answer to the question that clinicians all care about: what patients do better on the ketogenic diet and what patients would do worse. We're talking about the cholesterol and cardiovascular risks. In the absence of any evidence-based guidelines on this, clinicians who manage patients who are hyper-responders, meaning they have higher cholesterol when they eat a ketogenic diet, typically follow a pragmatic approach involving the assessment of other markers. So they don't just look at high LDL-C and high total cholesterol. They also look at LDL particle number. So the NMR lipoprofile test would give them that. They look at triglycerides. They look at HDL cholesterol. And they look at the coronary calcium score, the CT heart scan you hear me talk about. All of those as an adjunct to the high cholesterol markers are good. This is why you should never be trusting of any one marker to put you on a drug, to do any kind of therapy. You also want to look at family history of cardiovascular disease. If these markers are altered, patients may consider stopping the ketogenic diet and starting a cholesterol-lowering medication. With patients who express a desire and willingness to give keto a try, a common practice is to have them reduce their red meat and then replace the saturated fat with unsaturated fats and experiment. So that's the sidebar with cholesterol that I thought you guys would find really interesting. Let me get back to the main part of the paper. The next one is inborn genetic conditions with effects on the ketogenic diet response. With only a few common SNPs have been shown to affect the ketogenic diet response in clinical trials, several rare mutations can cause inborn errors of metabolism and have strong effects of a ketogenic diet response, representing either an indication or a contraindication for its use. So the ketogenic diet is contraindicated and potentially lethal in individuals affected by IEMs. That's the inborn errors of metabolism. We're going to get into some of those here in a minute. That prevent the body from using ketones or fatty acids for fuel, such as inborn defects of ketone metabolism, as well as fatty acid oxidation disorders. A special case of these FAODs, fatty acid oxidation disorders, is this thing called CPT1A deficiency, and it's due to the so-called Arctic variant, which is the most common CPT1A allele in indigenous Arctic populations. It is extremely rare in the general population. In contrast to the mutations causing primary CPT1A deficiency, which completely abolish enzymatic function, the Arctic variant has modulary effects on this that decrease its baseline activity but increase its activation in the context of diets high in omega-3 fatty acids and ones that are low in carbohydrates, like those in the traditional Arctic populations. This might explain its positive selection in those populations and the potential risks that this variant may pose in view of the recent shift to a Western diet. So you look at these populations like the Inuit, Eskimos, very well-known ketogenic population, and they didn't run into any trouble in their health until they started adopting a westernized, and I will say obesogenic, high-fat, high-carb diet. That's when they started having trouble. But it's because of this CPT1A gene that they started having the trouble, because their body was more adapted to eating whale blubber and keeping the carbs low. It's the Arctic, so there's hardly any vegetation, pretty much a carnivore diet, and that's how they survived. Other inborn conditions provide an indication for the use of a ketogenic diet as a first-line therapy or an adjunct therapy to improve symptoms and outcomes. These conditions, listen to this, and we included a lot of these in my book, Keto Clarity, but glucose transporter 1 deficiency, the whole GLUT1 deficiency syndrome, pyruvate dehydrogenase deficiency, drug-resistant epilepsy, glycogen storage disease, mitochondrial disorders, urea cycle disorders, purine metabolism disorders, amino acid metabolism disorders. Most of these conditions, with the exception of the glycogen storage disease, present with seizures, impaired brain function, and neurological symptoms that show significant improvement on the ketogenic diet through complex but not yet fully elucidated mechanisms. So I think the reason a lot of these have had the ketogenic diet attempted on them is, okay, we know, very well know, for the past 100 years, in fact, it was 100 years ago, that they were using the ketogenic diet for controlling seizures. Very well known brain dysfunction. And so they're like, okay, all of these are brain dysfunctions, let's give it a go. And so it's kind of cool that they're seeing some efficacy there. All right. So towards evidence-based recommendations, there is still insufficient evidence for the use of these genetic variants for the prediction of the ketogenic diet response. Thus, that's why they wrote this paper. They wanted that evidence to be presented and created. While some variants can have strong effects on the ketogenic diet response, these variants are found in rare congenital disorders and therefore not relevant to the majority of the population. On the other hand, common SNPs that are widely represented in the population have small effect sizes and work together with other gene variants and lifestyle factors to affect complex traits to the ketogenic diet response. Future studies with robust design and adequate power should replicate and quantify the associations observed in intervention studies of the ketogenic diet response, test additional promising candidate gene variants. See, we're still in the process of learning all of these genetic variants out there. They haven't found them all yet. As they find new ones, then that becomes a part of the conversation to be studied. And then identify new variants along the way. This will ultimately facilitate the development of prediction models that quantify the contribution of each of these variants on ketogenic diet outcomes, as well as their interaction with dietary intake and other risk factors. So, what are these promising candidate SNPs that are associated with the ketogenic diet? So we have selected based on the two following criteria: the location within genes that are mutated in rare diseases with strong effects on ketone metabolism and fat metabolism, and associations with metabolic traits in observational studies. The discovery of new genetic variants in large, well-designed studies will be critical for the development of more accurate prediction models of the response of the ketogenic diet. For personalized patient profiling, data sets from large interventions could be used for predicting an individual's likelihood of a successful response before they even go on the ketogenic diet. Would you have liked to have known, by the way, before you went keto, running all these markers and the way that you would do keto? Wouldn't you have liked to have customized it specifically that I should do this and a little bit of that based on my genes? Is this not an exciting development in the ketogenic space? It's easy to just tell people, well, just cut your carbs, eat more fat, and moderate your protein, but it's not making it customized to that person. And what these researchers are promoting is, let's make it more personalized. Keto is definitely powerful, but it's only powerful if it's done when it's done for your specific needs, not just willy-nilly. And this is why some people don't see results when they go keto, because they didn't customize it to who they were and their specific genetic traits. Data sets from large interventions could be used for predicting the likelihood of success. And what they could use is your age, your height, your sex, your baseline weight, and all the outcome variables such as macronutrient composition, total amount of calories consumed, expected weight loss, seizure reduction. For example, a model of this kind could predict with a greater than 80% accuracy the probability of whether you will lose more than 5 pounds of your body weight after following it for a year. That would be really cool. Could you imagine if you're a practitioner and you tell the patient, hey, I've got just the ticket, the little formula here. Let's run these tests. Let's see your genetic markers. And I'm going to guarantee you will lose at least 5% of your body weight if you follow this protocol for a year. Now, people with 5%, that's not a lot of weight, but 200-pound person, 5%, it's 10 pounds. So, you just kind of take it and do what you got to do. So then let's look at the polygenic scores. The most relevant study of ketogenic diet response could be used to develop polygenic scores, which enable greater power than the individual SNPs for the detection of interactions with environmental factors like diet. Polygenic scores provide a more quantitative metric of an individual's genetic likelihood to express a trait, such as the ketogenic diet response, based on the cumulative impact of these common SNPs. Weights are generally assigned to each SNP according to its strength of its association with the trait. Individuals are scored based on many alleles that they have here. All right, I don't want to bore you too much. Dynamic biomarkers is the next section. Let's see. So things like metabolic, epigenetic, transcriptic profile, microbiome, all of these identify hub genes that will regulate gene networks interacting with environmental factors. These biomarkers rapidly respond to dietary manipulation and interact with your physiology and lifestyle factors, things like activity, insulin resistance, stress. Once you implement ketogenic therapies, require oversight, especially in vulnerable patient populations. One such tool that they are proposing in this paper is the glucose to ketone index. You probably heard of GKI. It is a value used to describe the ratio of glucose to ketones measured in millimole per liter in the blood of individuals on ketogenic metabolic therapies. So they've looked at preliminary data from animals and small human trials suggesting that GKI may successfully predict therapeutic efficacy in those who have brain cancer. Similarly, subjective qualitative markers like self-reported appetite, energy levels, sleep quality may also predict candidacy, compliance, and efficacy of the ketogenic diet. Impairments in one or more of these areas may support initiation, alteration, and discontinuance of the ketogenic diet depending on the individual. All right, let's see. One other marker is the monounsaturated fatty acid, palmitoleic acid. Palmitoleic acid is the primary fatty acid in the product of de novo lipogenesis. So that's what you want, de novo lipogenesis, to take place. It is produced from palmitic acid by sterol-CoA saturase 1, increasing proportionally more than any other fatty acid when dietary carbohydrate is provided in excess, driving up this de novo lipogenesis. So beyond its role as a surrogate for de novo lipogenesis, greater abundance of this palmitoleic acid is the circulation in the membrane, tissue membranes, linked to metabolic things like obesity, metabolic syndrome, type 2 diabetes, heart failure, cardiovascular disease, and more. Thus, higher proportion of plasma palmitoleic acid is an early indication of carbohydrate intolerance, meaning keto would work really good for you. I want to wrap this up because it's still, okay, we're at the end. So they had one more section that they have for study design. So they're obviously asking for studies to be done on the ketogenic diet using these genetic markers to kind of customize it. So here's how they propose the researchers do it. While this review focused on genetic variants of ketogenic diet response, it's also a call to action to all researchers, clinicians, and funding institutions to establish common standards for study design and variant interpretation for the field of nutrigenomics as a whole. This will enable the building of a solid nutrigenomic knowledge base and accelerate the implementation of nutrigenomics in precision medicine. I love this because if you don't standardize the measure by which you know what a ketogenic diet is, if the researcher is the one that's left to interpret what that is, you're going to be all over the board. And that doesn't help anyone. So if we standardize the study design, that if you're going to call it a ketogenic diet, it has to fall within this parameter, that's helpful, right? I think so. The scientific validation of nutrigenic variants will require the use of larger sample sizes, common definitions for dietary protocols. In other words, you can't call a 50% carbohydrate diet ketogenic in one study, and then another study it's 20 grams. No. Patient stratification to evaluate heterogeneity of response in different patient subgroups. Large sample sizes will minimize both false positive and false negative associations and enable the replication of the most significant associations across the studies. I love that, standardizing what it means. Reproducibility of results will also require the establishment of common standards defining what constitutes high fat, what constitutes low carb, what constitutes a ketogenic diet. All of these are variable, highly variable from study to study, as the effects of a high-fat diet are heavily dependent on the quantity and the quality of the carbs consumed. A valuable method of defining a ketogenic diet may be one that they have to test for ketones and getting blood ketones to at least 0.5 millimolar higher. I love that idea. All right, you think that 50% carbohydrate diet in your study makes it ketogenic? What were their ketones? I've asked that many times when I've read studies here on Jimmy Rants. Would you have ketones in a 50% of your diet coming from carbohydrate? No, unless it's significantly hypocaloric, and even then it's iffy. So future studies of the ketogenic diet response should also evaluate modified ketogenic diet protocols that's tailored to different subgroups of people. The goal is both personalizing and expanding the application of the ketogenic diet in the clinical setting. All right, we're almost done, you guys. Thank you for sticking around. This is an important paper. The clinical implementation of genetic variants of ketogenic diet response and the nutrigenic variants in general will also require the development of a rigorous framework for variant interpretation. A model for such a framework is the partnership between ClinGen and ClinVar, two efforts of the National Institutes of Health, the NIH, to support genomic interpretation and implementation. The ClinGen program employs expert panels to assess the clinical validity and actionability of disease-related gene variants, which are then shared with the public through the ClinVar database. Building a similar framework for the interpretation of nutrigenic variants will require several steps. Number one, the development of common guidelines and the establishment of expert panels for the identification of scientifically valid and clinically useful variants. Number two, public sharing and crowdsourcing of these variants through clinical testing labs, research institutions, public databases, and professional societies. And then finally, number three, the creation of working groups to refine and update the guidelines as they are tested and deployed by the community. Taking these steps will greatly accelerate the implementation of this in clinical practice. Guys, this is huge, which is why I wanted to bring it here today for you on Jimmy Rants. If you joined us late, again, this is a paper that was published in the BMJ Nutrition, Prevention, and Health. The title of it, Genetic Variants for Personalized Management of Very Low Carbohydrate Ketogenic Diets. Lucia Aronica, Jeff Volek, Angela Poff, Dominique D'Agostino, 4 superstars in the ketogenic research world. And guys, they're onto something. Can you imagine if we identify these various genetic SNPs and can help the patients go on a customized keto that's based on their genetics? Like, this is exciting. I could even see like some flow chart up on the wall. Okay, if you have this, and this, it leads to this version of keto for you. Now, obviously, it's your mainstream doctor's office. They're not going to do this. But I see functional medicine doctors taking this and running with it. And I think it's an exciting next step in the ketogenic lifestyle. All right, let's see what you guys have to say. We're going to come here first to Instagram, then over to Twitch, then over to Facebook, finally over to YouTube. Thank you all for being here today on Jimmy Rants. I know this was a little bit more technical than I like to get, but I do like to bring you cutting edge stuff. And this thing is literally off the presses. In fact, yesterday I was interviewing, I think it was yesterday, might have been day before yesterday. Yeah, day before yesterday, I interviewed Dr. Eric Westman and Amy Berger about his new book, In the Carb Confusion. And in that interview, he's like, yeah, and there's this new study that's come out from Lucia Aronica. And I'm over here going, oh, you mean this one? He's like, of course, Jimmy Moore has that study by his side. Cutting edge, guys, cutting edge. But let's go here first. JimmyRants.com is the website. Go check it out, you guys. Thanks so much for being here today. Bridget says, this sounds interesting. It is interesting. The ketogenic way being promoted and used by more doctors will be causing many to get off their meds. Big Pharma would lose money. They would, Bridget. And I'm hoping it's embraced by a lot of mainstream medicine practitioners. This is exactly what I wanted to do with my clients, but I need more knowledge about keto and certification. Well, you can definitely run a lot of these SNPs. I would definitely be on the lookout. If I find any, I will definitely share them in my work where you can have these run. But it does seem helpful to know what your genes are and then to make appropriate actions based on those genes. Joshua says it makes sense from a survival standpoint. If women lost weight very quickly, that wouldn't be good for childbearing. So that's right. So I talked about that one genetic variant that says men lose weight better and faster than women do. And women get frustrated by that, but you're right. From a survival standpoint, that's why women have more trouble. All right. Thank you, Instagram. I see nobody is asking questions on Twitch. Thank you guys for being here, though. Over here to Facebook. Let's see what you guys have to say on this. What's up, Facebook? Welcome, welcome, welcome. Tracy says, I have IBS issues since my gastric bypass, so I have to eat heavy protein and I'm mostly carnivore. That's great. And that works for you. You have to adjust your way of eating to your own body. Yep, always. Debbie says, do you know if 23andMe gives you information on genetic markers? It does. 23andMe will run the basic genetic SNPs on a lot, not the full panel. So I told you Dr. Ben Lynch is sending me his panel. Look up Dr. Ben Lynch over here on Instagram. He's got this huge panel of genetic variants I'm real excited to run. I'm not sure if it's going to hit some of the ones that I mentioned today, but I definitely am interested to see what he finds out. But yes, 23andMe does have many of these markers, and I don't think they offer very good help in interpreting. I know Dr. Rhonda Patrick has like a little tool that if you run the 23andMe, you can run your numbers through her tool and it helps to interpret what it means for you. I found that my body does best at very low carb. This is also interesting. It took me 2 years to figure this out through trial and error. Yeah, a lot of people, they do trial and error. And, you know, quite frankly, that's a good way to do it. But you can save yourself time and frustration by running these genetic markers and seeing how the keto would work best for you. All right, thank you, Facebook. Let me pop over here real quick, see if there's anybody on YouTube that had a question or a comment. Charlotte says customization would be great. Yeah, like that. I think that's always been the goal. It's kind of ludicrous to think, oh, go keto, and then that would be exactly the same for everyone. That's what's gotten us in trouble with the dietary guidelines, which, by the way, guys, as of today, the 2020 dietary guidelines are now out and ain't good. So I will be addressing the 2020 dietary guidelines in an entire Jimmy Rants next week. So stay tuned for that. We will have that available to rant about. But yeah, customizing it is definitely the goal. V Rose, hello. Thanks for being here. Well, thank you for being here. Appreciate you watching. So guys, I know this was a long one today, but hopefully it was educational. And thanks to Lucia Aronica, Jeff Folick, Angela Poff, and Dominique D'Agostino, I think this is just fabulous. Customized keto, personalizing it to you, the individual, based on your genes. Who knew, right? We got the technology. The technology is there. We should definitely be taking advantage of it. Hello, Becky, over on Twitch. Thanks for saying hello and yay. All right. I love your rants. Well, thank you, Mai. I appreciate you watching, and I appreciate you, all of you watching, and I try to always bring you cutting-edge stuff here, so appreciate your support. And that's it for this episode of Jimmy Rants. JimmyRants.com is the website. And as always, you can engage live in the content. Go follow me right here on Instagram. I am Jimmy Rants on Instagram. Go follow that. We're here Monday through Friday, 11 a.m. Eastern Time. We also simulcast on Twitch. Thanks for your work. You're welcome, Becky. As well as on Facebook and on YouTube. So all the family of Jimmy Rants, thank you all for being here today. If you missed the live, you can watch it on the replay on the Jimmy Rants IGTV. It goes up right after we're done. I throw a few little notes in there and it goes right up on the Jimmy Rants IGTV. We also put the past episodes up over on YouTube. If you type in a keyword Jimmy Rants, you will find the show. Finally, go to JimmyRants.com, the official website for this show. You can see all the past episodes there. Okay, you guys, tomorrow I have an article where they're going to try to use psychology to persuade you to take the 9,1-divox V word. And so, psychology, to me, if it was that great and if it was such a overwhelming, oh my gosh, I have to take that thing, you don't need to use psychological tricks to get people to take it. So we're going to see what they're going to try on this. Yeah, you're going to enjoy that one. And then, of course, Friday we have Ask Me Anything. So thank you so much for being here today, and we'll see you again tomorrow. Bye.